Hello, everyone. So I'm excited to be here. Today we're going to be talking about going from imperative code to declarative. But before we jump into that, I just want to introduce myself. So my name's Ryan Olson, and first and foremost, I'm a husband and father to 4 kids, which is awesome. Oh, thank you. Yeah. I'm a staff software engineer at Omni, which is now a JP Morgan company. We were acquired earlier this year. And we're also hiring. So if you're looking for some amazing opportunities, come check us out. Right now at Omni, I'm on the front-end platform team. And we do a lot of Next.js and React. And so hopefully you can get some value from some of the things that we've learned with declarative code. So back to the premise, going from imperative code to declarative code. Let's first talk about what those are before we talk about the how. So we're going to look through an example of taking a taxi to Olive Garden, as you do. So let's first look at an imperative example of this. So you get in the taxi, and let's say you like control. You're like, taxi driver, I will tell you where to go. And he's like, all right, okay. So you say, all right, go straight, turn left at Madison, turn right at State Street, go straight for 5 miles until you see it on the right. We made it. Awesome. Travel time, 20 minutes. Not bad. All right, let's look at a declarative example of this. You get in the taxi and you tell him, can you take me to the Olive Garden in Salt Lake City? And he's like, sure. Okay, so he starts driving, takes a turn, another. You're just relaxing, enjoying your favorite podcast, whatever. And then all of a sudden, he takes this different road that maybe you wouldn't have taken. You're like, where did this long road come from? And he tells you it's a new highway. And we're there already. Travel time, 10 minutes, 2 times faster than imperative. Now, let's talk about what happened here. So in the imperative example, we provided every instruction. Every single direction was dictated by us. We had full control, which can be useful at times. But we were also limited to our own knowledge and experience with this area. Now, in the declarative example, we just provided where we wanted to go, the end state we wanted. It was simple. We were able to just sit back, relax, let the expert do what he does best. The taxi driver was in charge of the how, and he avoided closed roads and knew the optimal routes, like that new highway we saw. This is the kind of thing you can achieve by writing declarative code. Let's look at some code, shall we? So we're going to look at an imperative example. Let's say you have some sales representatives in your application, and you want to filter them down to US sales reps. So we make a function. We take in the sales reps. We create an array of US reps that we can push into, loop through each of the sales reps, and if they're part of the USA, then you add them to that array and you return it. Okay, this is well and fine. Now let's look at a declarative version of this. So this one's more declarative. I wouldn't say it's entirely declarative, but when we use the .filter function on an array, we can give it a predicate. It tells you a little bit more about the what rather than the how. Or if you want, you can dive into functional programming a little bit, use Lambda, and get real declarative where you don't even see the variable sales reps. You just have a filter function where you can filter anything that has a country by USA, but maybe functional programming is for another talk. All right, so I'm going to tell you this now. You use declarative code all the time, whether you're front end, back end, and let me show you some examples of what you might do that's declarative. SQL queries are declarative. You're not telling the SQL engine exactly how it should filter down your sales reps. You're just kind of telling it some parameters and constraints on how you want it to query the database for your sales representatives and how you want to order them. And on the front end, HTML, it's declarative. You give it your content, you give it what you want to have on your website, and it takes care of it for you. In an imperative example of this, we would have had to tell the browser, set the tab's title to hello UtahJS. And you would have to tell it, here's my content, here's how you draw it on the screen. No, we don't do that with HTML. So it's declarative. And then, of course, if you use React.js or any other language that uses JSX, you're using the same sort of construct, where it's declarative. All right, cool. So let's talk about some benefits of declarative code. One of the first benefits I can see is you can have a simple API for reusable code. And this is something you can create or use. And it provides a nice mental model as you're doing your work. You don't have to worry about how to draw the content on the screen with HTML. You just use it. You're able to create abstractions over implementation details. Abstractions can be really great, especially for reuse if you make the right abstraction. And it also allows you to change the implementation without breaking the API. This can be great for performance, can be great for preferences or the latest and greatest thing in React. And last but not least, declarative code, I believe, scales with complexity. In many imperative examples, like that for loop I showed earlier, that code's fine. Like, if you were to read that in a code base, I'm sure you can follow it, you can debug it, it's pretty easy. But as you add more state and more imperativeness to it, I believe that it doesn't scale well when you add that complexity. I feel like it adds more complexity on top of your domain that you're trying to model. And if with declarative examples, in my experience, I've seen it handles complexity well and is able to scale with that. Now, footnote, declarative code is powered by imperative. Eventually, you got to get to an imperative layer. And this usually is handled by the programming language, if you're in a functional programming language, or in the case that I had earlier, the browser doing the imperativeness of your declarative HTML for you. Or it might be handled by a library or a framework. Or sometimes you write the imperative code and you wrap it in something where you can use it in a declarative fashion. All right, so now we know what it means to have something be imperative or declarative. Let's get back to our original premise. How do you go from imperative code to something more declarative? Specifically, how can I simplify JavaScript APIs and make them declarative? Let's learn that by looking at the Google Maps JavaScript API. So if you look up the docs for Google Maps, they'll give you something along the lines of this. So you create some sort of global variable to keep track of your map once it's initialized. You create a init function. And when you call into some of Google's code, you can say, I want to grab the maps library, and it'll give you a map constructor. You figure out where you want to mount that on the DOM, you create some initial data, and you new up your map. It's able to mount it, you call init map, and voila, you get a map. And look, that's us right there. All right, so let's add some code to change the zoom level, still doing it in an imperative fashion. So let's say you have this input element on your website. You want to be able to have it be a range where it steps through incrementally and changes your zoom. Well, you can grab that element, add an event listener, and whenever it changes, you can call map set zoom. What else can you do with map? So there are many APIs that you can call within a map object. You can set the zoom, set center of the map, and that's like the focus, the bounds where you're looking at. You can change the map type. So if you're more interested in a satellite view or terrain view, you can change that. You can also add event listeners. You can see if the user is interacting with the map using the native Google Maps controls and get events back. All right, and there's so much more. That was just really the tip of the iceberg on that. All right, so the API for this library, it's pretty imperative. So imagine you wanted to use this in React. You're like, okay, I can throw that in there. but what if we can make it look like this? I think that would be pretty nice to be able to drop that into my application wherever I needed to use Google Maps and have a good abstraction. On top of that, with these props that it accepts, I want it to be able to react to those. If I have some sort of state that changes what the center of the map is, I want Google Maps to update. So let's see how we can do that. Well, first we'll need a Google Map component. Okay, so we created a basic Google Map component here. One thing to call out is something that's important with Google Maps is you do need to size it. And so we're going to pass class name as one of the attributes for where we're going to mount this Google Map. That way you can provide the sizing info. All right, let's initialize it, similar to that imperative example. Okay, so you typically need to grab the Google API key that you're going to use, and we're going to use a custom hook to abstract away the initialization logic. What it's going to give us from that useMap hook is the ref that you can mount to your div, and then the map instance, which we can use later. So let's look at some of the basics of that hook. So we're going to take in that API key, the initial center and zoom that we want for the map, and then we're going to create a few things here. So the first thing we're going to do is create that container ref for where you mount this, and then we're going to create the map as a ref. Now, can anyone think about why we might use a ref here rather than use state? Well, if you check out the docs for use ref, there is this case where if you have something that you want to keep track of and you don't want to recalculate it through each render, you can store it in use ref. And if your rendering isn't dependent on that value, then you can just keep it within there, and then whenever you have event handlers or anything else, you can update that and then later access it. So that's perfect for example here, because we're mostly trying to control this imperative API that will update this rendering of Google Maps. And then we just return those. All right, okay, so let's actually initialize it now. So in that last bit there, we were just kind of setting up the foundations of this hook, but let's take it further. So Google provides this really nice loader, and this is something we were somewhat using in the imperative example. It allows you to give your API key and specify the Google Maps version that you want to use. And Google, they don't want you to use its explicit version. They just let you use, okay, I want to use the weekly version or monthly, and so that's what we're going to use down here in this use effect. Well, let's get closer there. Okay, so when we call this useMap hook, we only want to run it on mount. We don't want this to ever run again after we've created an instance of map, because after that, we have the map we can use. So we call this new loader, and we give it our API key. And then, just like the imperative example, we call import library maps, and we're able to get a maps constructor. And we can call that with our data stored in that ref for later use. Okay? So this is what the hook looks like by the time we're done with it. And we're able to return that map that we just initialized. Awesome. Okay, so let's try it out. We see the map rendering. Success. All right, so we created the Google Map component, but let's handle the props now. So let's say we want to take care of the center of the map. This comes in useful when you want to have some sort of control, like up there, where you might want to change the map's location and what you're focusing on by some input control. In this case, it's just some simple radios that swap between Salt Lake and London. So your application code, where it's using Google Map, might look something like this. You keep track of that radio state, defaulting to Salt Lake. When that changes, you calculate the center, and you just look that up in this object here that maps to latitude and longitude. And then you pass that along to the Google Map. And then this is the thing that can update the location. Okay, cool. Let's use that map that we initialized in the Google Map component now. All right, so there it is. We have that available for use. And we have that center prop coming in. So let's make a hook that's just called useCenter, and takes the map in the center. That's all we need for that. Now, this is a pretty simple custom hook. It's just as a use effect, and whenever the map changes or the center changes, we will call the use effect and do that imperative code where we're calling a setter. So we're going to set center here. All right, check. We have that functionality. If we were to try this out and we swap between those two different locations, we would see the Google Map change, and that's coming from outside of this component. All right, so we rinse and repeat that pattern for Zoom. We make a custom hook, call it, and that one works as well. So you can easily have whatever sort of controls outside of your map, changing these state values and have them flow into your component, have things update. All right, last but not least, on idle. So this is one of those events that we saw you can tap into. We can create a custom hook for that as well. This one, just a little different, still using use effect. And whenever these two things change, it will run the effect. And so we're able to add a listener. So whenever the user goes idle on the map, you can do something based on that. And then, of course, you got to clean up after yourself. All right, so not bad. Let's do a little bit of extra credit. So something that is common when you're using Google Maps is you want to pinpoint something on the map, whether it's a venue that you want to route someone to or just some interesting location. And so usually you use something called a marker, and you give it a latitude and longitude position. Well, if we change up our code that we just wrote, we can change the map to a use state, because later, as you'll see, we'll actually use the render of this to handle that marker. Okay, so not too bad. So we swap this one out to use set map, and then from here we can just return map. Now we can use context within this Google Map so that as we render any child components, they can access the map that we've created, that we've initialized. And that happens here where we have the provider newed up with the map. And then once we have a map, we can render children. Now, if we were to create a marker component, we can use that same map context here, grab the map, and in a similar fashion to the maps import library that we used before, we can grab the marker constructor, new that up with a position, and associate it with a map. And if we were to have some code that said we want to center on Salt Lake City, and our marker is at megaplex, we can do that, shows a marker, huzzah. All right, so you might be thinking, this is just a bunch of use effects. This isn't anything new. Or you might be thinking of that last talk where it's like, should I be using use effect? You know, yeah, it's just a bunch of effects, and that's okay. There's a time and place for the good old use effect. And of course, like Mike North said, you might not need a use effect, but in the case, we need them. We're reacting to changes in props and doing some external things by calling into this imperative library. You know, and also, if you disagree, you know, you can change it. Your consumers will never know. You can swap out those implementation details. Let's say everyone's in favor of signals. You can swap to signals as long as it's inside of that Google Map component, and anyone who's using that doesn't have to care. There's actually a pretty dang good Google Maps React.js library out there. Suggest you look at that if you're going to be using Google Maps, or you can roll your own, kind of like what I was showing. And it does the same sort of thing. Reacts to changes in props and runs use effects to control Google Maps. But to wrap up, I just want to say that switching to a declarative API gives you a more simple and stable API for your consumers of your component. The implementation is encapsulated, which is really great. And in my opinion, it allows for better code. Thank you.